Yeah, I could do that. No.
I answered all. I answered 6.
Is it a paper quiz or is it?
Yours is paper. I'm trying to see if I have I had a Desmos version of it for the online, but I can't find it for some reason. So, we have to have them. All right, guys. Here we go. Clear off your desk. So, when you get this, you will notice that it's got, I'll just kind of show it from here. At the top, 5 questions where you have to plot the points and label with the letter. Then at the bottom, you'll see 6 through 10. It's got the same letters, and it tells you like B, I want it as a plus plus. Okay. L, I want it as a negative positive. So it's telling you. All you have to do is to the right of those, you can just write down your answers then. Okay, so you plot these, and then you're rewriting the coordinates in the form I've asked for here. Right? Okay. You don't get even a whole period for this. Do you want to take it?
Sure.
Okay.
I tried to do it yesterday.
Okay. That is not. That's more than 4 rotation. So just subtract 2 pi from it to find out what angle I'm asking it for.
Mm-hmm.
That's all.
And then are these right? Because I know like on a regular line, it's like positive, negative.
That's nothing to do with this. Yeah, that's why you needed to look at the notes. So, like, this is telling you it's a negative radius. So you have to first, you always want to start by doing the angle. Okay?
Mm-hmm.
From standard position. Once you've done that, then you either go out along the terminal side if it's a positive radius. And if it's a negative radius, you go the opposite direction of the terminal side. Get me an extra copy over there. I'm just going to do a couple. So let's say I wanted this. This is a new one. 6 negative 3 pi over 4. Okay? So you go, okay, here's positive 3 pi over 4. That's going this direction. Negative 3 pi over 4 would be here. This would be negative 3 pi over 4 if I went this direction. Remember how there's positive angles and negative angles? So I start by doing my angle. So my rotation is here. Now, if I come out along this side, that's a positive. If I come out along it. If I go out along the opposite, like this would be a negative radius. So that's why this first number can be positive or negative. So this, you would come to negative 3 pi over 4, and you would go out a positive 6. 1, 2, 3, 4, 5, 6. Boom, there it is.
So it's not going to necessarily be the right one.
Okay, let's say I did another one like this. Now let's say I did negative 3, comma, negative 3 pi over 4. All right?
So I do my angle. But since it's a negative radius, I don't come along the terminal side, I would go the opposite direction. Okay. There you go. Yep. Done? Oh,
So it's negative, but it's already negative.
I want both negative though.
Okay.
That
So
means
just both
this is just, I mean, this is a
Just keep
mistake.
it.
Yeah,
Just
that's, yeah, so it's negative, negative instead. That's all you have to do. And you label them, like letters?
Yeah.
Okay, yeah, that's fine. That's all you gotta do.
I like darkened it because I know it was like it is. It is. Okay,
Yeah.
I was just making sure.
Yep. Thank you. This. See.
All right. So everyone needs to have out the Chromebook because we're going to start using that today for Polar. I'm going to hit the lights. Okay. All right, so let's do this. So up here, I have it bookmarked over. This is just like a regular Desmos graphing calculator. So it's just set and ready to go. So once I'm in here, the first thing I'm gonna do is I need to get into Polar mode. And that's very easy to do. It's just all about going over here to the wrench, okay? And you'll notice right here, there's these two circles. The green one's highlighted, that's rectangular. Next to it is a polar. If you click it, it changes it to polar coordinate system. Plain and simple. The other thing I want to make sure I'm in is I'm in radians because we're doing everything in radians right now. So here it is, radians, and I'm good to go there. So now I can close that and be out. Now remember, everything I enter needs to be in r comma theta. So we're not talking x's and y's here. I just gave you a quiz. The very first one was -3, -5 pi over 12. -3, comma, -5 pi over 12. Notice it plots it for me. Boom, it's done. Okay. You can see it right there. You can zoom in on it. You can click on it. It will give you its values. Okay. So this is really nice. Home screen takes me back. There it is. Okay. Now, you guys know how to change colors. And how many of you are pretty good with Desmos? I know a couple of you are. Okay, so a couple things. One, if I had given this to you as an online quiz, you could have clicked label and then you could have put the letter B here and boom, this would have been like how we would have done it. But if you're just typing it in and labeling it, are you really plotting it? No, you're just entering stuff. So that's why I didn't have you do that. But I want you to be familiar with using this. Another thing is today we're going to be doing an activity in here. You have to change the colors. The easiest way to change colors is if you come up to the color right here, you click and hold, and it'll show you the available colors. Okay. So the two colors we're going to be using today, I think I chose were blue and black. It's like here, if I click this, now it makes it blue. If I click this, it makes it black. Plain and simple. Okay. So we can easily go ahead and get that set up like that. All right. I'm just going to close out of that. Now, So this is the polar graph you're going to be using in here. Okay, the polar coordinate system. In a second, I'm going to give you a paper, and we're going to do the very first one together, and then I'm going to ask you to complete this and work on it, and then we're going to go through it and see what you guys found out. So let me pass this out. Yeah, Ryan? It probably does. Well, you have to zoom in on that one. I'm not sure if it's. I don't know. Let me go ahead and look at it real fast. Hold on. I'm not sure why that's not. Where's my scale set at over here? Let's get this out of here. I'm not sure why that's not putting it. So, okay, so here's what you'd have to do then. So do you guys, if you want, because I wasn't really worried about plotting points on here. I forgot about that. Do you guys remember from, like when we did the coordinate system, and if I put a point here that was an X and Y like this, okay, and this was R, we found out that there was a relationship here. X was equal to R times the cosine of theta, and Y is equal to R times the sine of theta. So what you could do if you were doing this, looks like, that's what it's kind of going through there, is I would have to use that knowledge. So you're not going to need that for what we're doing in here on this in a second, okay? I'm not going to ask you to plot points. So not going to worry about that right now. What I'm more interested in is the graphs. I know the graphs will be fine when we start graphing them on here because you're going to put in R's and thetas, okay? So we can do that later if you want to. So here we go. Everyone look at what this says to do. It says use Desmos and graph each equation and sketch what you got. Answer the following questions. So here's the first thing I want you to do at the top of your paper. Any equation that has cosine in it, I want you to make it blue, okay? And then any equation that has sine in it, I want you to make it black. Because just so you know, because if you want to graph two of them at a time and see what goes on, it might be a good idea. And that's kind of how I'm going to approach this a little bit, all right? So again, all the cosine ones, I'd like you to do them in blue, and then the sine ones, I want you to do them in black. So I'm going to go ahead and type in the very first one that says R equals 8 cosine theta. Okay, I'm literally going to type it in. R equals 8 cosine. Now, here's the thing. Theta, you have to go to the keypad right here, hit the ABC, and then way over here on the far right-hand side, there's a theta button. What's that? You can type theta if you want. Okay, so you can do this. You can type it, just like you can type pi or whatever you want. Now I'm going to go back to my screen here. Right away, you'll notice I get this. I wanted it to be what color? Blue. I said. I'm going to hold this down. Blue. Okay, now. So that's what you're going to sketch. Now, before I go any further, I'm actually going to graph number 3 at the same time, and I want to look at it. So right below this, I'm going to graph r equals 6 sine theta. Okay. And that will be black. I'm going to make it black so I know which one's which when I'm looking at them. All right. So somebody talked to me about, what do you notice? What's different? What are they both forming? They're both making circles. Okay. Where is the cosine circle at? On the x-axis, kind of. Yeah, I agree with that. It's on the right-hand side over here, isn't it? Right? The sine is where? Above. Okay? So when you graph these, you'll know. So this one here, this is the cosine, this is the sine. Now you're going to sketch those as separate ones. Okay? You're going to sketch those as two separate graphs. So we just did number 1 and 3. Now you're going to do 2 and 4, and then I want you to answer the questions right below it. It asks you, what is going on? Can you tell me what is going on with those values and what they do to the graph? How do they relate to the graph? Okay, I'm gonna Mr. McManus, guess what they're doing right now? Polar graphs. I knew you would. I know that's what the worksheet even says. It's cold on it. So
this is the crew I'll be with
on Thursday, and there I can tell you right now, what they'll be doing is graphing like the sine, the circle, trying to find within six. We're trying to find like one, like try to find values of theta which they may not know what they want.
Yeah.
Um,
Well, I don't know how to do it either, but I can make it.
see, that's good. Yeah, just make an answer that I know it's right. Snyder's wrong.
Did you tell me answers are $1 on here? Correct
That's
answers
cheap.
are 5. The correct answers are 5.
Oh, okay, good. Okay, yeah, that's good to hear.
And it's a double block. They come back to that.
You have yeah. I didn't eat already. You know any of it?
Well, they got masks on.
Yeah.
Should I know any of you?
You know Stacy? Bennington?
Oh, yeah. Honestly, with the and glasses, you didn't have glasses when you were in class.
Yeah, I got it.
So okay, I'm mistaken.
That's the only one you know. Wow. Anyone taking physics next year?
But I don't teach physics.
I know you don't, but you might see him over at least in your part of the building.
Yep. Well, all the physics students will be with Mr. Runyon this year. With Mr. Lindman retiring, shuffle things a little bit.
All physics one.
All physics, 6th grade physics. It's a rough day. Well, how do you think he's feeling?
Happy? Over
Yeah,
joy?
preps this year. It's going to 1. Feels like he can breathe again. Yeah. Yeah, it's good inside.
Thanks for doing that.
Yeah, no problem.
If you need to still.
What? I do the AP physics for senior, so if you're.
Well, I'll be thinking, I'm gonna talk.
Yep. So, if you're a sophomore, there's a chance I'll see you here.
Perfect.
Okay, so I'll be down here, and if you need to leave me anything before you go or whatever.
I probably won't.
Otherwise, it looks like they can handle themselves pretty well, and they'll have the keys.
All right, sounds good. Thank you, sir. Okay.
Go ahead, where is that sheet at? Let's print this to Desmos. Print to Smart Notebook. Print. Did it print? Hello? I don't think it printed it. Print. Print. What'd you have him for?
So, integrated science.
Oh, integrated. Got it. Is that freshman year? Yeah.
And I also see him walking by my house.
Oh, yeah, that's right, because he just lives over here.
So he's walking his dog.
Why is it not printing? Oh, there it is.
The diameter.
The first one's nine.
Oh, yeah. Yeah. Pretty sure. First one is diameter, the second one is radius.
What piece is
Take your break. You can keep working your choice, what you want to do. Yeah.
On my test, I think I'm writing, I accidentally put X on one of them instead of one.
You mean on this?
Yeah, like for one of the, I think I accidentally put like X instead of one. I was like, yep, I used X. Okay,
I'll take care of that.
thank you.
Yep. I've got a backside to do. It'll be done pretty soon.
Pretty soon.
Yeah.
Okay, because I think the exam is, we get that Thursday.
I don't know. I haven't looked at the thing yet. They're probably due by when? Next Monday?
I think they're giving them to us Thursday.
Have to turn them in by when?
Oh, you think we'd have to like turn them in?
You turn them into advisory at some point.
So you don't do it the same day?
No. No, so it'll probably be Monday you may have to turn them in by. So it'll be done by then, don't worry.
Because
We'll be
I
fine.
know I have a C. If I get a B, I get an extra exam.
Okay.
So
All right.
I was just seeing if I can get it.
Oh, I'm sure you can.
All right.
I think so. I think you do number three. There's one of these that.
Another 56-page chapter.
It was in next one.
I've been reading it.
I lost. Let's do it every Thursday. So it's like, I would recommend. I'm doing
Mrs. Hauge, how are you?
Where did we put the copies?
Oh, on that on that chair.
No. It's not as bad as Tinder. Tinder's sucks. He was literally about slavery. Wow. That's a good thing. Yeah. Oh. Me too.
See, that's.
He made fun of something. Oh, he made slavery. No, was that thing? Yeah, I think we're going to see higher.
The next problem is first move into the other giant. Hold on.
Let's just do that.
My brother got like 25. He showed me. And then I tried to play it. And I thought I could probably make better than my little brother. Yeah, it's kids but I couldn't do it. Burger game. Burger. Have you read it? No, you're not. You will. No, it's gotta be fair. We had them. And then he could be for like a week. Just let me know. You're like, no, you're not. You're gonna keep it. You're gonna do that. No, I was not. You're literally, she's gonna say, she's literally supposed to like, nah, yes, I would. It's literally like 4 o'clock. I'm not gonna do what do you say one said technically last night, he was like, great. Do you have cookie clicker? It was like, great. No. And he was like, hey, I have cookie clicker. We'll have a talk. Remember like that. Whoever will do the next week, I have to buy the other guy one. Then I called him. We're not doing it. I'm gonna be lots of sit down and do cookie clicker.
I'm still good with the for today. Yeah. Yeah, you can have it. Side, issue blue. Issue blue.
Yeah, well. Wait. Oh, I just lost. I'm gonna get it on my phone. No, you can have it. No. Every class and I even. Yeah, go. I mean. Yeah. Yes.
Change that in the future. Notebook. See if you can get through these in about another, I don't know, 15 minutes. Be nice if it could be done in 15 minutes. We can go over this.
Yeah, you get rid of one. And pull that.
another 5 minutes if we could. What's going on? Okay. Let's go ahead and start going over these. All right. So we're going to look at these together and see what we notice about them. So the first ones, we already kind of talked about these a little bit. So on each one of these, I'm going to go ahead and I'm just going to draw what would be the polar axis. This is like the polar axis idea, and it's extended. This is pi over 2 axis, because there is no y-axis on the polar system. This is pi over 2. This is the polar axis. That's the idea. This one 2, got this one 2, and we got this one. So what do we know? So this, we should have seen, was a circle, and it was on the right-hand side like this. This was a circle that was on the left-hand side. This is a circle that is on the top, and this is a circle that is on the bottom. All right? Now we want to go through and talk about what these numbers are doing. What do they do to these graphs? So when we look at this, first of all, on either one of them, A is nothing more than the diameter of the circle. Okay, it's the diameter of the circle. Right? That means, of course, then that A over 2 determines the radius of the circle. Now, sine and cosine, what do they determine? They determine where it's symmetric. Okay? They determine the symmetry. Now, let's just talk about this real fast. Where do we notice that the cosines are symmetric? On the polar axis, right? So right here for the symmetry, I'm going to write myself a little note. I know that cosine is symmetric to PA, which stands for polar axis. Okay? Then I also notice that what? That the sine is symmetric to the pi over 2 axis is what we're going to call it. Sine, here's pi over 2. Cosine, this is like the polar axis going left to right. So that's where the symmetry occurs. So the sine and cosine determine its position symmetry-wise. All right? Now, real quick, let's talk about this a little bit. Here, guess what? I want everyone to look at this real fast. You remember the all students text constantly? Think about where sine is positive at. 1 and 2. Positive sign. Look where the graph's at. Up here. Look what happens when I'm making a negative sign. This is where sine is negative. Look here. Where's cosine positive? Quadrants 1 and. That's why when it's a positive 8 cosine, it's here on the right-hand side. It'd be like quadrants 1 and 4. And when it's a negative, that's why it's in quadrants 2 and 3, what we thought of before, because that's where cosine is negative. So that symmetry goes along with what we did in the past. Okay? Goes along with what we did in the past. We're okay with these, right? Circles. These are nothing more, this first batch up here is nothing more than circles. Okay, so then we get to this next batch here. Okay? Little different looking. I need some graphs here. I can't get them all on here. Maybe I can. Okay. So let's start with this one. Okay. This one is symmetric on where? Tell me where the symmetry is on this very first one. On the polar axis. Is it on the left or the right? This one, 1 plus 2 cosine theta. It's on the right. It looks something like this, kind of. I'm going to go ahead and make it a little bit bigger than that. That's going to be way too small. Kind of goes like this. That should be over the black line. It's not. It looks like this somewhat. This next one kind of goes like this. Okay. Those are the first ones. Those were the cosine ones. The sine ones, the symmetry follows just like it did up here. This one ends up being on top, and it kind of goes like this. Maybe redo that one. I'm not happy with that one at all. It goes kind of like this. Whoop, like that. And this one's on the bottom part. It's more like this. Again, not like that in the graph. Like this. Kind of like that. These two, different again, right? This is on the right, but all of a sudden it's different. It goes like this. And this one's on the left. And it looks like this. Okay? So all of yours should kind of resemble that a little bit. Now, let's talk about what these are all called. These fall under the category of what are called LIMACONS, and this has a little accent below it. They're referred to as limacons. They're called limacons. All of them are, because of the way they're written. Okay? Now, all of these here, the first three all have what is called an inside loop. See that inside loop on them? This last one does not have the inside loop on it. It's a special limacon. And this one down here is called a cardioid, because it's kind of shaped like a heart. Okay, a cardioid is what it's referred to as. It's a special type of limacon. All right, now, let's talk about what is going on with these numbers. So here we go. Again, I've got here bar equals a plus or minus b cosine theta, or a plus or minus b sine theta. Sine and cosine determine what? Again, they determine what? Where the symmetry is at. They determine the symmetry. They determine the symmetry of this thing again. All right? And you notice the symmetry is the exact same. The cosines are all symmetric to the polar axis. The sines are all symmetric to the pi over 2 axis. So I'm not going to write that down here again, where the symmetry is. All right, the value of A. The value of A. So that's this value right here. So on this, it's 1. On this one, it was 2. Okay, I'm going to go ahead and pull up Desmos and see what you guys think it is. So the value of A. Let's see. We are on, oops, that's the wrong graph. We're on, okay, 1 plus 2 cosine theta. Boop, boop. Let me pull this over. Okay, here we go. So here is, this is 1 plus 2 cosine theta. Okay, here, this is what it looks like. Okay, now, when you're looking at this, I'm asking you, what does this value of 1 here have to do with this graph? So I'm going to go ahead. You guys see the 1 anywhere on this graph? Do you see it anywhere? I have somebody calling in the middle class. Not okay. 333 is just matter. Does he need to come right now? We're in the middle of some notes that are kind of important. All right. All right. All right. So you probably see the number 1 showing up in this graph 3 times. Here, here, and here. There, right? Okay, I'm going to go ahead and change this value of 2, and I want you to tell me which of those x's stays where they are. So I'm going to make this 2 a 3. What did you notice? What happened? Some of them did not move. They stayed where? At the number 1. These two did, right? Okay, this one changed. So we know that that value of A is not this length of the inside loop, is it? Okay, so let's talk about this then. What is it? Well, this is the symmetric axis. This would be the non-symmetric axis. It's the what? Intercepts on the non-symmetric axis. Okay, it's this intercepts. I'm going to write this down here. A determines the intercepts on the non-symmetric axis. Okay, that's what that gives us. All right. A plus B. Now notice it's absolute value of A plus B, so we're ignoring the signs in between. So A plus B, who wants to tell me what those give me? Yeah.
It gives you gives you like the endpoint on like the larger root side.
Yep, so guess what this value is right here? 3. This is at 3. This is at 6. This is at, well, it is, but it's a -6, right? But it's still a 6, right? It doesn't, whichever way you want to think of it, doesn't really care what it is. It's 6 out, right? This is out how far? 4. It's out 4. That's what that's giving us. So it's the intercept on the what? Symmetric axis. It's where it's going to cross over the axis of symmetry on the outside. It's the furthest, or the maximum symmetric intercept, if you want to call it. Okay? So the A plus B, I'm going to call it, determines the intercept on the symmetric axis. How far out it goes. Okay? What about B minus A? Let's go back to that graph I did earlier. It wasn't one that you did. Let's look at what B minus A does. What would B minus A be on the one I have right here? 2. Look what this is right here. Where's this crossing over at? 2. Look at this one. Let's go ahead and come back out here. 2 minus 1 is at what? Negative, boom, 1. There it is, right? Let's go ahead and look at these. 2 minus 2 is what? 0, and that's where it's at. Because there is no, so what? It's the length of the inside loop. It's the length of the inside loop. Length of the inside loop. All right. And of course, when A equals B, what does that mean? There is no inside loop, right? There is no inside loop. That's when you get the what? Cardioid. So if A equals B, no inner loop. That means it's a what? Cardioid, we called it. Okay? All right. Are we okay so far? Hopefully. Okay, so these next ones, I'm going to go ahead and I'm just going to call the graph up instead of trying to sketch them real fast due to time. We're kind of trying to get through all this here today. Okay. So turn this off. Turn all of these off. Okay, so we're going to come down here. We're going to start with 2 cosine 5 theta. Here's what it looks like. Okay. Now let's answer a question right now, because one of the questions on your thing asks you the following. The first question says, I'm going to graph all of these at once. So the first question says, hey, what does the value of A determine? So I want you to look at this, and then I'll do this one, and I'm going to do this one as well. What is the value of A on the first one here? It's 2. Guess what that is? It's the maximum length of these. Now, guess what these things are referred to as? They're actually referred to as roses. That's what they're called. So we call each of those a petal, all right? So the value of A determines the length of the petal. Boom, that one goes out length of 3. This one has a length of 5. So for that very first question there, the value of A, that determines length of each petal. Oh, why didn't it type? Because it's in the wrong one. Length of each petal. Of each. Of each.
Is that only for the cosine?
No, that's for all of them. That doesn't matter if it's sine or cosine. That, yeah, on yours, I think I printed off the wrong one. It should have been cosine or sine. It's both. Yeah, I forgot to just do that. So it's the length of each petal, okay? Next one. It says if it's cosine or sine and n is odd, then the number of petals is. So let's go back and look at this. So I need n to be odd. So that would be this one here, and that would be this one here. How many petals does the blue one have? 5. How many petals does the black one have? What do you notice then? The number of petals is the same as what? N. So then on that part of your notes, all right, on that part of your notes, we are literally going to type right here, the number of petals is what? N petals. It's the same as N. Boom. It's N petals. Okay, now, then it says, what if N is even? So that was the next ones we were going to look at. So let me go over here to this. We'll turn these off. So here's this one, bloop, and this one is bloop, and you'll find out that if it's even, the number of petals is doubled. So it's 2n. So it's 2n petals. All right. Okay, good. Here we go. Then it says symmetry. Okay, here we go. If R equals A cosine n theta and n is odd. So let's go back and look at this. And n is odd. So we're talking about the very first, come on, move here. There we go. This guy right here. Where's the symmetry at? Isn't it symmetric to the polar axis still? If you flip this down, it's going to fold right on top of itself. So it is symmetric to the polar axis, okay? So for that particular question, if it's an R equals A cosine n theta and n is odd, it is symmetric to the polar axis. The one right below it says if R equals A sine n theta and n is odd, so that's this next question right here, it's symmetric to the what? Pi over 2 axis again. So we have those two things right now to fill out. So right there, you've got, oops. So on this one here, symmetric to, this one is polar axis. This one is symmetric to the pi over 2 axis. Then the last one says, hey, what if it's an even value of n? And it says for sine or cosine. Yeah, it's symmetric to both when you have that happen. The symmetry ends up being on both. So if I come down here and look at this, if I click this, you can see it's symmetric to the polar axis. It is also symmetric to the pi over 2 axis. Here, it's symmetric to the polar axis and the pi over 2 axis. Okay, boom. So this is both. Whoa, what in the world happened there? Okay, I have, why that even popped up when I'm typing? Both axes. Boom. What I want you to do is you're going to be looking over those things. This is something for you to have, okay? And then when you guys, oh boy, what I was gonna have you guys do on Thursday, there's no way you're gonna be able to do it. Thursday, I'm not sure what I'm gonna have you guys do, because you cannot do the next part without me here. I don't want to put, because I can't, my other class doesn't have McManus in here. Just, I don't know what's going to happen on Thursday. Things are going to change a little bit because what happened today. So Thursday, make sure you have Desmos, you have your graphing calculator with you. I might ask you to go ahead and try a few problems dealing with this. I might give you a couple examples. I might even put a video together for you to watch. So if you want to bring earphones so you can listen to it, that might be a good idea. You might watch a video of me doing some problems, and then you might try some like that. Okay, that's probably what's going to happen. I'll probably make a video tomorrow of what I want you to try on Thursday. So I would say bring headphones so you can listen to that on Thursday on your own, and then you can try the problems. Okay. Hold on, Mr. Wright. At the end of class, go see Ms. Pernovic, okay? Yes, Ryan. That, I don't know if we'll do that or not. That might get pushed back to Monday. Even though I don't like giving them on Monday, we might push it back to Monday. As a matter of fact, let's just plan that it's going to be on Monday right now. So there won't be a quiz Friday, it'll be Monday.
You're just gonna look at it. Isn't there an extension? Yeah, but it's a long one. You can't see. No, there was. No, there was. No. Then she, that's why she's doing it. She does photos instead of just having two from one or whatever. She has a photo and it can't train that.
Have a good one, guys.
Her son's in the class? Yeah. Why did you do it? Oh, no, she doesn't have them. Her daughter's in my class. My mom. Yes.
Print this.